Hello everyone and welcome to the lecture on Amazon Rekognition. So this lecture will contain all these topics. What is Amazon Rekognition? Key capabilities, API operations, labels in Amazon Rekognition, Amazon Rekognition custom labels, Amazon Rekognition face liveness, detecting and analyzing faces. So what is Amazon Rekognition? Amazon Rekognition is a cloud-based service designed for comprehensive image and video analysis, making it easy to add advanced visual processing capabilities to your applications. The service leverages cutting-edge computer vision capabilities powered by deep learning technology, enabling it to perform complex visual analysis tasks with high accuracy. Despite its advanced capabilities, Amazon Rekognition is designed to be user-friendly. It does not require users to have machine learning expertise, making it accessible to a wide range of developers and businesses. Rekognition offers a simple, easy-to-use API that can quickly analyze any image or video file stored in Amazon S3. This integration with S3 makes it seamless to process large volumes of visual data. Amazon Rekognition provides a range of powerful features such as object detection, which identifies and locates objects within images and videos, text recognition, which extracts text from images and videos, unsafe content identification, this flags inappropriate or offensive visual content, image and video analysis, provides detailed insights about content of images and videos, facial comparison, this detects, analyzes and compares faces within visual content. These capabilities support a wide variety of use cases, including user verification for security purposes, cataloging of visual assets, people counting for analytics, and public safety measures. Developed by Amazon's computer vision scientists, Rekognition utilizes highly scalable deep learning technology. It is capable of analyzing billions of images and video on a daily basis, demonstrating its robustness and efficiency. The service is designed to evolve continuously. It routinely learns from new data and frequently incorporates additional labels and features. This ongoing development ensures that Rekognition remains at the forefront of image and video analysis technology, constantly expanding its capabilities to meet emerging needs. So let's see some key capabilities in the area of image analysis. So first we have object scene and concept detection. This detects and classifies objects, scenes, concepts and celebrities in images. Next we have text detection. This detects and recognize printed and handwritten text in images in a variety of languages. Unsafe content, detect and filter explicit, inappropriate and violent content and images. It also detects granular unsafe content labels. Celebrity recognition. It can recognize tens of thousands of celebrities in your images across different categories such as politicians, athletes, actors, and musicians. Facial analysis. It can detect, analyze, and compare faces along with facial attributes such as gender, age, and emotions. Use cases may include user verification, cataloging, people counting, and public safety. Custom labels. So you can build custom classifiers to detect objects specific to your use case, such as logos, your own products, and characters. Image properties. You can analyze image properties like quality, color, sharpness, and contrast. Next is under video analysis, the key capabilities are object, scene, and concept detection. It can detect and classify objects, scenes, concepts, and celebrities in videos. Text detection. It can detect and recognize printed and handwritten text in videos in a variety of languages. People pathing. It can track identified people as they move across video frames. So this is especially useful in sports. Facial analysis. It can detect, analyze, and compare faces in streaming or stored videos. Celebrity recognition. You can recognize tens of thousands of celebrities in your stored videos across different categories such as politician, athletes, actors, and musicians. Then unsafe content detection. It can detect explicit, inappropriate, and violent content in videos. Video segmentation. It can automatically identify useful segments of videos such as black frames and end credits. Face liveness. It can detect if a live user is present during face verification. Okay, this is just the list of API operations. You can pause the screen if you want to take a look. I'll just quickly summarize. So you have moderating content. So it will be look like this. You have images or stored videos, identity verification, images, stored videos, facial analysis. So type of media. So it can be images or video or streaming video. So what all it's applicable. So you have a use case, you have a category like whether images or stored video. So in some cases, it's also streaming video is also supported. For example, connected home, streaming videos, and media analysis. So streaming will be real time and stored will be stored in S3, and then it will be analyzed. And how you will initiate what you want to do. For example, there's the API operation which you have to call. For example, let's say facial analysis. You have to call this API called detect faces, compare faces, start face detection, get face detection. So for example, in the case of text detection, you have detect text. And let's say one example of streaming video. So for example, connected home, you have to call this particular API start stream processor to start your streaming video analysis. Okay, labels in Amazon Rekognition. So a label refers to any of the following. So it can be an object, for example, for a flower, a tree, or table. So basically it's detecting objects. Then it can be an event. It can detect whether there is some kind of event happening. For example, a wedding, graduation, or a birthday party. Concepts. It can be, for example, landscape, evening, and nature. So this is just a representative example. Actual things it can identify will be very high, will be quite large. It can detect activities. It can find out whether it's running, playing basketball, or any other sport. So Amazon Rekognition can detect labels in both images and videos. So label detection capabilities. Rekognition can detect a large list of labels in both images and stored video, as I talked about. Rekognition can detect a small number of labels in streaming video. For streaming, it's less because it's real time and it has to make judgment at a very instant. Okay, now operations for label detection. So this is similar to as I talked about the API operations. So you can use the following operations to detect labels based on your use case. For example, in the case of images, the operation you have to call is detect labels. And additional capabilities are identify image properties like dominant image colors and image quality. You can use detect labels with image properties as input parameter. Next media type, stored videos. Operation is start label detection, and again detection of dominant image colors and image quality is not supported for videos. Okay, and for streaming video, you have to call this create stream processor. Detection of dominant image colors and image quality is not supported again, but only for images, dominant colors and image quality is supported. Okay, one tip, you can specify what types of labels you want returned for both image and stored videos label detection by using inclusive and exclusive filtering options. This is one example code. So how it looks like. So you start this is a Lambda function. So you will have you will initialize the recognition API or library. You have like recognition client, Boto3 client recognition. Then you can just call the recognition.client.detect labels. So it will. So you will, in this case we are using image detection. So you will specify input parameter as a bucket, file name, and you are setting the maximum number of labels to return and set the minimum confidence threshold for the labels. So it will return all the labels that it has returned, and you can iterate through the detected labels and print them. So what was the confidence score and the image label. So here we have not specified any filter, so it will just iterate all the labels. That is, so we are just doing for one image, right? So it will just give that image properties, all the labels that is associated with that, and what is the confidence score. So confidence score in the sense, for example, if this image is a flower, right? If it is a flower, or it can be something like a fruit, right? So let's say there are two labels. So it will say flower is 70%, but fruit is 50%. So it will give a confidence score saying that the model thinks that flower chances is this being a flower is 30% or fruit is 30%. 30%. So it will be total 100%, right? So it will. So if there is one more label, so let's say 40%, 50%, and 10%. So the label will tell what is the confidence in judging whether this object is this label. Okay, important. Always ensure you have the necessary permissions and credentials set up during when using AWS SDK operations. Okay, next topic is Amazon Rekognition custom labels. So already I talked about that it has built-in capabilities to identify a huge number of labels by itself, but in some use cases you have to create your own custom classifier to have your own custom labels. So image recognition custom labels enables businesses to identify specific objects, logos, and scenes in images, tailoring the image analysis to their unique business requirements or business needs. It builds upon Amazon Rekognition extensive capabilities, which are trained on millions of images across various categories, offering a robust foundation for custom image analysis. The service revolutionizes the model training process by requiring only a few hundred images or less, which can be easily uploaded through user-friendly console. It accommodates both pre-labeled images for quick training and provides option for tagging unlabeled images within the interface or via Amazon SageMaker ground truth. Custom labels automates the entire model creation process from data inspection and algorithm selection to model training and performance metric generation, completing these tasks in just hours rather than months. The resulting custom model is readily accessible through Amazon Rekognition Custom Labels API, facilitating seamless integration into various applications. And this streamlined approach significantly reduces the time, expertise, and resources typically required for custom model development, enabling rapid creation of specialized image analysis solutions for a wide range of use cases. Okay, so here I just talk about Amazon's SageMaker ground truth. So this service is used in case you want to provide your own custom images or your own images and your custom labels. I want to say. So let's say you have a business, you have your own company logo, and you want to identify your company logo, for example, in a social media feed like a Twitter or something. So how much it's trending, whether your company is being trending or not, or you have, so let's say, your own custom name or something. So text detection. So you can using this technology, SageMaker ground truth, you can provide your own 100 images, for example, and you can label them with your company name. So this model, which is based on which has a baseline model from the recognition, you build on top of that, so it can identify the regular objects, and then if it finds your company name or company text in social media feed, it can identify and tell you whether that belongs to your company or not. Okay, Amazon Rekognition face liveness. So Amazon Rekognition face liveness verifies a user's physical presence during facial verification by detecting spoof attacks. Users complete a check via a short video selfies following prompts. The system returns a confidence score between 0 to 100 and a reference image for face comparison. The key components of this technology includes AWS Amplify SDK, which can be consist of React, iOS, or Android, with face liveness detector, and AWS SDKs and AWS Cloud APIs. The process looks something like this. You integrate face liveness with face-based verification workflows using AWS Amplify SDK. Then SDK manages user interface and feedback during video selfie capture. When user's face enters the on-screen oval box or the capture box, SDK displays colored lights and streams videos to the cloud APIs. Cloud APIs perform real-time analysis using ML models, and the output you get is face liveness confidence score between 0 to 100, and this high quality reference image for face match and search. you can audit up to 4 audit images from the selfie video. Usage note: face liveness is probabilistic and should be used with other factors for risk-based identity decisions. So this technology can be used in, let's say you're developing some security system, and a person has to, when enter, they have to stand in front of a camera and they have to take a selfie, or there'll be square box around faces. So it will check that whether the face is live or not, or somebody is just like holding a photo or whatever, and will check with the how you have set up the security check at the first time, whether somebody is spoofing or not. So it will check in real time, and it will get back you the score between 0 to 100. So if it's a highly mission critical system, you can set a threshold. For example, the confidence score should be more than 90%. Then only allow the person. If it is less than, so based on your scenarios, you can have set up certain threshold to basically identify whether the person is real and live or not, right? Okay, now last topic is detecting and analyzing faces. Amazon Rekognition provides a comprehensive suite of APIs, and this is different from face liveness. This is a different topic. Face liveness was for real-time detection, and this is for in general detecting and analyzing faces. Okay, Amazon Rekognition provides a comprehensive suite of APIs for detecting and analyzing faces in both images and videos, offering non-storage operations for various facial analysis tasks. So non-storage means you don't have to keep in S3. You can directly upload in real time, like upload, or you can directly use. The system's capabilities include detecting facial landmarks, analyzing emotions. So facial landmarks are like facial features which is very specific to you. Detecting facial landmarks, analyzing emotions, and comparing faces. It can identify specific facial features like eye position, detect emotions such as happiness or sadness, and recognize attributes like the presence of glasses or face occlusion. For each detected face, Amazon Rekognition conducts a detailed analysis of facial attributes and generates confidence scores for each identified attribute, allowing for nuanced understanding of the analyzed faces. While the primary operations don't store facial data, Amazon Rekognition offers separate storage operations and face collections. These features enable users to save facial metadata from detected faces in images, facilitating subsequent searches across both images and videos. So as you are using this, the metadata, like when did you timestamp on the wall, will be saved into its own face collection or facial metadata. So it has its own separate storage to keep the history of all the faces that it has detected. And the combination of real-time analysis capabilities and optional storage features makes Rekognition a versatile tool suitable for a wide range of applications, including security, content analysis, and user experience enhancement. And that's all. Thanks for watching.